Bismillahirrahmanirrahim. We continue with seconds ADC circuit, which is counter ramp converters. These counter ramp converters, also known as stair-step ramp, or also we can call digital ramp ADC. So the basic idea of counter ramp converter, kita connect outputs of free running binary counter to the input DAC, and then kita compare output analog DAC dengan analog input signals, and then the signal will be digitized. Okay, and then we use the comparator outputs to tell the counter when to stop the counting and reset. Okay, this is the basic ADC block. So we have sample and hold circuits. So this sample and hold circuit kita gunakan untuk samplekan input voltage untuk analog dan maintain it. So untuk comparator input voltage VA. So VA kita tak akan VA kita do not change during the analog to digital conversions implementations. So that's why we need sample and hold circuits. Okay, and then ADC timing will be controlled by an external clock signals. So when ADC receive a signal start, so the control logic comprise the logic circuit, and then the process of conversion A to D in order to produce the correct sequence of operations. And then the logic circuit will always modify or increase the value of digits in the form of binary numbers stored in the register at the time specified by the clock signals. And then digital to analog converter DAC is used to convert the digital outputs to check the voltage analog equivalent to the value of that digit. And the operations amplifier act as comparisons to, kita akan compare VA and VB. Okay, and then VA is a voltage to samples and hold circuit, and analog voltage VB is equal to the output digitals. Okay, while VB less than VA, so the comparator output akan remain high. So bila mana VB greater than VA, so comparator output will show low and stop the process of modifications of binary number in a list. Okay, at the time the VB, okay, which is equivalent to the digital, almost equal to the input of VA, and logic control signal active, okay, conversions is complete. EOC to low, indicating that the conversion of AD has been complete. Okay, now that the basic of ADC. Now we move to counter ramp ADC. So this is the block diagram, okay, for counter ramp ADC. So we have the gate here, we have the logic here, and then we have the comparators, the binary counters, and then the DAC and bit. Okay, the n-bit binary counters used as a register that allow the signal list that allow signal in binary counter increasing step by step until the voltage VB greater than VA. So ADC is called for counter ramp. Okay, ADC is called for counter ramp that form the ramp of stair. Okay, dia akan form VB kita akan form the ramp of stair. So that's why they call counter ramp. So the comparator output EOC will produce an active signal low when the VB greater than VA. So VB analog voltage equivalence to the digital outputs is very similar to the analog input voltage VA. So ADC operations begin with counter ramp considering analog output voltage to the sample and hold circuit that VA is positive. So when the command signal start is enabled, so instead of high, okay, the binary counter will be clear and the clock signal will be blocked by gate N from reaching the counters. Okay, this is the operations of RAM ADC. So DAC analog output increase the process and then will continue until the VA and VB exceed the amount of equal or greater than the threshold voltage VT, where VT is among 10 microvolts to 100 microvolts. At this point, the signal EOC will be low and prevent the clock signal from reaching the binary counter, and the counter stop countings. And then the conversion process is complete as shown as the following figure by transition high to low signal, at which the output is a binary digit representations of analog input VA, and then this will keep the digital counter until the pulse start reactivates. Okay, when the counter is increments, bila kita incrementskan counters by one digital output step, okay, kita akan by one digital output step, the DAC analog output voltage VB. So kalau kita tengok VB kat sini also increase lah. So increasing dia by like a stair. Okay, that's why we call the counter ramp. So in this outputs VB, we have the VT here. So VT is V with threshold. So in calculation after this, we need to consider the VT. Okay. Now we move to the examples. For 8-bit, for example, we have 8-bit counter ramp ADC. So given the frequency of the clock signal F frequency clock 1 megahertz, the threshold voltage VT equal to 0.1 millivolt, and the full scale voltage 3.825 volts. Now determines the digital output when the analog input is VA equal to 1.824. Okay, kita nak dapatkan berapa value digital output kita bila mana input kita 1.8. Okay, and then conversion time kita berapa, and then voltage resolution kita berapa. Okay, now because of we are using 8-bit, we need to calculate the total step 2 power of 8 minus 1, so we have 255 step. Okay, and then to calculate the step size, we have the full scale voltage. Okay, full scale voltage dia bagi 3.825, so we divide by total step, so kita akan dapat step size ataupun kita punya resolutions adalah 15 millivolts. Okay, now because of the analog input VA adalah 1.825 volts and the threshold voltage VT equal to 0.1 millivolt, so the VB kita need to reach adalah yang kita nak kira adalah 1.8241. So kita plus 1.825 plus 0.1 millivolts. Hence, the total step need to VB to reach is 1.8241 volts. So we can calculate the total step that we need to reach is VB yang kita plus dengan VT divide by step size yang kita dah kira sebelum ni. So kita calculate, kita akan dapat 121.6 is equivalent to 122 steps. So the digital outputs of ADC is equal to 122, kita convert kepada binary, so kita akan dapat 0.111010 in digital. Okay, so this is the digital output of ADC. Okay, to calculate the time, okay, the conversion time, so the conversion time equal to number of step needs multiply with cycle clock. Okay, so kita punya number of step needs adalah 122. Okay, and then kita punya cycle clock, kita punya frequency clock adalah 1 megahertz. Okay, so kita boleh calculate time kita. So time kita adalah 1 over F. So kita akan dapat 1 microseconds, and then kita bila kita multiply, so kita akan dapat conversion time kita adalah 122 microseconds. Okay, now for the voltage resolution also same with step size, so kita akan dapat 15 millivolts. Okay, and then I suggest the student should do this exercise 1 to get more understanding on this topic.